So block 4, electricity and magnetism. The last we discussed the, about the current, voltage and resistance of the circuit. In this session we'll discuss the circuit diagrams. So at the beginning of the circuit diagram you have to learn the circuit symbols. So draw and interpret circuit diagrams containing like switches, resistor, fixed and variable, heater, thermistor, light dependent, ammeter, voltmeter, and draw and interpret circuit diagram containing diodes. So these are some circuit symbols. So the first one on the left hand side, you can use this as a symbol for lamp. A circle with A is a symbol for ammeter. A circle with B, a symbol for voltmeter. A switch, this is an open switch. A switch, if it was a closed, then it will be connected. When positive and negative, only one like big line, another one small line, it means it's a cell. And when we have several cells together, we call that as a battery. Then we have AC power supply and DC power supply. So this one, so AC power supply and DC power supply. So alternating current supply or AC power supply can change its direction continuously. We represent by a wave here between the two terminal, and DC power supply does not change the terminal, so we represent by positive and negative charge. This is a symbol for resistor. A variable resistor, a resistor which can change its value, we call that a variable resistor, a symbol for variable resistor. Light dependent resistor, a resistor which resistance changes with the light, so that's LDR or light dependent resistor. Fuse, diode, light emitting diode, magnetizing coil, electric bell, and a relay. So you have to learn these circuit symbols again. This from the syllabus only. So symbol for cell, for battery or group of cells, power supply, AC power supply, junction of conductor means where the two wires are connected, lamp, fixed resistor, variable, thermistor, light dependent, heater, earthing or a ground, then a switch or an open switch, electric bell, electric buzzer, microphone, loudspeaker, motor, generator, ammeter, voltmeter, and galvanometer. So these are the circuit symbols which you have to learn. Potential divider circuit, relay coil, transformer, diode, light emitting diode, fuse, oscilloscope, AND gate, OR gate, NAND gate, NOR gate, and NOT gate. All symbols you have to learn. Then electricity and magnetism, the circuits in series and parallel circuit. So when we have series and parallel circuits, or when we have circuit, the circuit which is having only one way for the charges to flow, we call series. If we have multiple ways for the charges to flow, we call parallel. Series circuits will have the same current and parallel circuits will have the same voltage. But sometimes we have a combination of series and parallel circuits. So starting with the concept of a circuit is a region where the charges can flow. So DC circuits can be series circuits. Like as you can see here, the charges have only one way to flow. And if one of them is faulty, like if one of the component is not working properly, either like example a 6 ohm is not working properly, the whole circuit will stop. Same thing, if a 6 ohm is working properly but the 4 ohm resistor there is a fault, so it means the whole circuit will stop working. So in series, if one of the component is faulty, all the component will stop working. And when we compare the current is same in series. So in series circuit, when resistor or other component are connected in series, the current at every point is same. So what is the current coming out from the battery? The same current will pass through ammeter, same current will pass through 6 ohm, same current will pass through 4 ohm, and same current will return. So if I say The current is 1.6 ampere, which is coming out from the battery. So if there is a current of 1.6 amps or 1.6 ampere that is coming out from the battery, so same current will flow through ammeter, same current will flow through 6 ohm resistor, same current will flow through 4 ohm resistor, and same current will return back to the battery. So the total current which enter the circuit is same as total current leave the circuit, and current through each component will be same. But what about the voltage? Like the same circuit, when we discuss about the voltage and how to get the total current before finding the voltage, how to find the total current, because they are connected in series, 6 ohm and 4 ohm are connected in series. So what is the total circuit resistance? The combined resistance of the circuit will be the sum, because they are in series. So 6 plus 4 or 4 plus 6, so combined resistance is 10. Now we need a total current, so we use the formula V is equals to IR, where V is the total voltage of the circuit and R is the total resistance of the circuit. So voltage is 16, current we don't know, and the resistance of the circuit is 10. This 10 is multiplied, other side it will be divided. So it will be 16 divided by 10, and when 16 divided by 10, we'll get 1.6 ampere. So 1.6 ampere is the total current which flow through the circuit. And that current will be same as current in each component. But what about the voltage? The voltage will divide between the component. Like if the total voltage is 16 volts, so this 16 volts will divide between the component. How to know what is the voltage across 6 ohm and what is the voltage across 4 ohm? So again we use the formula V is equals to IR. Now we want to find the voltage here. So we know the resistance and we have the current. So the current is 1.6 and the resistance is 6. So 1.6 times 6. So the voltage will be 9.6 volts. So voltage across this is 9.6. Same thing, voltage across 4 ohm. So if total is 16, if 9.6 volts is here, the remaining 6.4 volts will be across the other component. Or you can also find that, how to find, because we know the resistance it is 4 and we know the current. So we'll again use the formula V is equals to IR. I is the current which is 1.6 and R is the resistance which is 4. So 1.6 multiplied by 4 will get as 6.4 volts. So the total voltage, like 9.6 plus 6.4, that sum will make 16. So the total voltage or sum of the potential difference in the series is equal to the potential difference of the whole circuit, or we can say EMF of the battery. So this was about the series circuit. Like if two or more components are in series, they will have the same current, but they will have a different voltages across them. And the voltage across the component depends on how much current is passing and what is the resistance of the component. Then we have parallel circuits. So when two or more components are connected in parallel, the potential at every point is same. What does it mean? Like example, if we have, this is a 18 volt, so this will be 18 volts and this will also be 18 volt. They will receive the same voltage. And how to know the current? So voltage will be same 18 and 18. So voltage of the battery will be same as voltage across each component. But what about the current? The current, how to get the total current of the circuit and how to know the current across each So we know the voltage across each is 18 and we know its resistance is 8. So we have the formula V is equals to IR, or V divided by R is equals to I. V is the voltage, which is 18, and R is the resistance, which is 8. So 18 divided by 8, so 2.25 ampere. So means the 2.25 ampere will flow through the 8 ohm resistor. And when we check how much current is moving through the second resistor, we know that its voltage and we know the resistance. So V is equals to IR is there, or V divided by R is equals to I, where V is the voltage, which is 18, and R is the resistance 2. So 18 divided by 2, that's equal to 9 ampere. So it means 9 ampere will flow through this one. So you can clearly see that the one which is having a high, if two resistors are in parallel, the one which is having a high resistance, smaller amount of current can flow through it. The one which is having a low resistance, greater amount of current will flow through that component. Because less resistance means charges can flow easily, so that's why there's having a higher current. And what about the total current? Because 2.25 is moving from here and 9 ampere is moving from here, so it means this current will be sum of 2.25 plus 9. So 2.25 plus 9, that is equals to 11.25 ampere. So 11.25 is the current which enter the circuit, which divide, when it enter the branches, it divide into 2.25 and 9, and when it flow out, like here it will be 2.25 amperes, this will be 9 amperes, and when it flow out it will become 11.25 ampere again, and the same current will return back. So the total current which enter the circuit is always same as the total current leaves the circuit. But that because the branches are there, so the current divide between the component. So current from the source is the sum of the current in separate branches of a parallel circuit, or the current will divide in the branches, and the branch which is having a low resistance will have a high current, and the branch which is having a high resistance will have a low current. Then what are the advantage of connecting the component in parallel compared to that in series? In parallel, like example, if these lamps, they need 240 volts. So if we connect them to a 240, they all receive the same voltage. But that problem, when we connect them in series, the voltage will divide. So this will be 120 and this will also be 120. So the advantage of connecting them in parallel, they all receive the same voltage. And another thing, if one of them is faulty, like if one of the component is not working, the other component will continue as normal, like they will work normally. Like if this lamp 1 is not working, the other lamp will continue to work. But what happens if lamp 1 or lamp 2 is not working in series? The whole circuit won't work. So they work independently in parallel and they receive the same voltage. So if the voltage through each lamp will be same, so each lamp will have the same brightness or receive the same rated voltage. The second thing, if one of the lamp is melt, or a lamp melt, filament of the lamp melt, then the whole circuit won't work. Now some questions related to the circuit. Like we have to draw a circuit diagram with a 1.5 volts power supply of fixed voltage, because power supply can also have a variable voltage. So 1.5 volt power supply. So first we draw 1.5 volt power supply. So you have to learn the circuit symbol. So this is 1.5 volt. Two bulbs are connected in series. So two bulbs are there. And these two bulbs are connected in series. So this is a series combination of the bulb. Then there is a switch. So switch should be next to the battery or the supply, and you always draw an open switch in the circuit until unless they mention switch must be closed. So the two bulbs connected in series with each other, and then they are connected to a power supply in series. Then we have to connect an ammeter to measure current through, because they are in series, so they will have the same current. So we can connect ammeter anywhere. I can connect next to the supply, I can connect next to the bulb 1, or I can connect next to bulb 2. Voltmeters to measure voltage across each. Voltmeter are always connected in parallel, so we'll connect a voltmeter to measure the voltage across each component. So this is how we draw the circuit in which two lamps or two bulbs are connected in series with a switch, an ammeter and a voltmeter. Is it clear? Discussion? So this is the final figure is shown. Here 1.5, but actually it was 15 volt supply. Another question, draw a circuit diagram, include a 15 volt power supply. So we have a 15 volt power supply. When power supply is there, and if they mention AC power supply, then you should draw like this. This is a symbol for AC. But only if the power supply not mention which power supply, so you'll take a DC power supply. Two resistors are connected in parallel, each rating 5 ohm. So what is the circuit symbol for resistor? So it is a rectangular box, and each is having a rating of 5 ohm. So means each is having a resistance of 5 ohm. A switch, so a switch should be there next to supply switch. Ammeter to measure current through the circuit. So current through the circuit means we want to measure the total current in the circuit. So if you want to measure the total current in the circuit, then ammeter should be connected next to the power supply. If they ask measure the current in each resistor, then the ammeter should be connected in series with the resistor. So because they are asking for to measure the current through the circuit, so it means the total current, so ammeter before or after the power supply. Then there should be a variable resistor also connected, which can change the voltage. So variable resistor to change the voltage. So this is a circuit symbol for variable resistor, a rectangular box and then arrow, so which can change the voltage or current in the circuit. So this was about electrical circuits. Now some more questions related to electrical circuit, like we discussed a series and parallel, but we may have a circuit in which we have a combination of series and parallel. So example, there are circuits which might have series and parallel both combinations. Say this is a supply and we have two resistors in parallel, and next to them there is another resistor in series. Because there is a resistor in series to them, so the voltage across the two parallel will not be same as the voltage of the battery, because some of the voltage will drop across this series resistor and remaining voltage will be there across the parallel combination. So the voltage of the battery won't be same as the voltage of the parallel combination. Like if this is 20 volt battery, 20 volt supply, here it won't be 20 volt. That will be wrong. Because what happens, some of the voltage is consumed here and energy consumed here, remaining energy will be across the two parallel resistor, and that will be same because they are in parallel. So if I say this is a 10 ohm resistor, this is also a 10 ohm resistor, and this one is say 5 ohm resistor. Now, the first part of the question, there's an ammeter here connected. So the first part of the question is find the total resistance of the circuit or combined resistance of a circuit. This is a common question they ask. So how to find the combined resistance of a circuit? First, these two are in parallel. So what is the formula for parallel? The product divided by sum. So 10 multiplied by 10 divided by 10 plus 10. So 10 multiplied by 10 is 100, divided by 10 plus 10 is 20. So when we simplify, the combined resistance will be 5. Means the combined resistance of these two will be 5 ohm. Means it will appear like this is a 5 ohm resistor. So this is 5 ohm resistor and next to that is also 5 ohm. And they are in series now. So 5 plus 5. So the total will be 10 ohm. So the answer, the combined resistance of the circuit is equals to 10 ohm. Then if we want to find the total resistance of the circuit, total current in the circuit, to find the total current in the circuit, we should know the total voltage and we should know the total resistance. So we have the formula V is equals to IR. So the total voltage, that's the total 20 is the total voltage. I is the current we don't know and R is the total circuit resistance. And how much is this? The total resistance of a circuit as we calculated 10. So this is 10. 10 is multiplied, other side it will be divided. So it will be 20 divided by 10 and 20 divided by 10 is equals to 2 ampere. So the total current which enter the circuit, that is 2 ampere. So 2 ampere enter the circuit, the 2 ampere will flow. It will divide among these two branches and then when it recombine it will be 2 ampere here and it will flow out, the same 2 ampere will return, but it will divide between the branches. So if I say what is the voltage across 5 ohm resistor or potential difference or voltage, sometimes they say potential difference PD or sometimes the word voltage is there across the 5 ohm. So voltage or potential difference of the 5 ohm, how we can work out that? So we have the formula that V is equals to IR. So we know the resistance is 5 and the current is 2. So V is equals to IR. So current is 2 and the resistance is 5. 2 multiplied by 5. So that's equal to 10 volts. So if this is 10 volts, so around this one, this is a 10 volt. So if this is 10 volt, how much voltage will be there across? Because the total is 20. Out of 20, 10 volt drop across the 5 ohm. So remaining 10 volts will drop across this 10 and the other 10. Because they are in parallel, even if there is another resistor in parallel, they all receive the same voltage in parallel. And because they have the same resistance 10 ohm and 10 ohm, so when this 2 ampere will enter, this 2 ampere will divide into 1 ampere across 10 ohm and 1 ampere across the other 10 ohm, and then it will rejoin to form 2 ampere again. So this is a circuit in which we have both series and parallel combination together. Is it clear? A circuit with a combination of a series and parallel. So another example, a circuit with the combination of series and parallel. So this is also an example of a circuit which is having a combination of series and parallel. Like two are parallel and then next to them is a series combination. So if I say this one is, say, example 4 ohm, this one is 20 ohms, and this one is also 20 ohm, and the supply is of 10 volts. So the question is, find the combined resistance of the circuit or total resistance of a circuit. And electricity questions, actually questions are interrelated, so when you solve one part then you can solve the next part. So even in exam they don't ask to solve the whole circuit by yourself, they ask step by step, so you have to use your understanding or knowledge of the circuit and work out the voltage, resistance of or current using different formulas. We'll do at the last, like after this discussion, we'll do the example questions as well related to circuits. So there's a 10 volt supply. First there's a series and then it is parallel. So it's a combination of series and parallel. So if it's a 10 volt supply, we cannot write 10 volts and 10 volts. It will be wrong. Why? Because there is another resistor present before and that is in series. So out of 10, some voltage will drop here. Remaining voltage will drop across these two parallel resistors and they will have the same voltage because they are in parallel. So to get the combined resistance, first we'll find the sum. They are in parallel, so it will be product divided by sum. So 20 multiplied by 20 divided by 20 plus 20. So 20 multiplied by 20, 2 multiplied by 2, 4, and double 0, 400, and that is 40 when we simplify. So this will come out as 10 ohm. So means the combine of these two is 10 ohm, or the result of these two is equals to 10 ohm. So when 4 ohm from here and 10 ohm from here, so what is the total resistance? So it will be 4 plus 10 or 10 plus 4. The combined resistance is equals to 14 ohm, because the parallel combination and then there's a series. So first we got the result for the parallel combination, which is a product divided by sum, and then we add to a series resistor. So we get the total resistance of this circuit. Then if we want to find the total current in the circuit, so V is equals to IR, or I is equals to V divided by R. So V is the voltage, the total voltage is 10 and the total resistance of the circuit is 14. So it will be, because the combined or the total resistance is 14, so it will be 10 divided by 14, that is equals to 0.71. So it means 0.71 ampere. 0.71 ampere is the current which enter the circuit, and same it will divide between these two resistors, and then same it will return back to the supply. 0.71 ampere will return back. So now we know the current in this 4 ohm. So we can find, if we say potential difference we want, or PD across the 4 ohm resistor, or voltage across the 4 ohm resistor. So V is equals to IR, where I is the current which is 0.71 and R is the resistance 4. So 0.71 multiplied by 4, that's equal to 2.85. So voltage here is 2.85. So voltage which is dropped across this, that voltage is 2.85. So out of 10, 2.485 is voltage or energy used here. Remaining energy will use between these two and they will receive the same amount of energy. So 10 minus 2.5, 10 is a total voltage minus the voltage across the series combination. So 7.15, so voltage here, remaining voltage 7.15 volt across this one and 7.15 volts across the other one. Why? Because they are parallel, so they will receive the same voltage. And to know the current here if I want to find what is the current in example, say this is R1, this one is R2, and this is R3. So if I want the current in R2, so current is voltage divided by resistance. So voltage is 7.15 divided by resistance is 10. So 7.15 divided by 10, which will give 0.715. So 0.715 ampere will be there passing through this, and this will be voltage is 7.5 divided by resistance is 20, so 0.35. So the product, this was 10 ohm, the 14 was there, and 10 divided by 14 was 0.71. So we have 0.71 multiplied by 4, so that is 2.85, and then minus 10, so that 7.14 was there, which is the voltage across these components. So using this we can work out the current in each combination. Now we'll do some questions related to the circuits.